Okay, this is a talk on promise theory and accusation theory, and then some remarks on fracterms and transrationals. Altogether, the work involves these 4 people, besides myself, Mark Burgess, Marcus Duell, and John Tucker. Second occurrence of this mistake. Right. Now, Mark introduced promise theory, well, not on a date that I would know, you would know better, but more than 10 years ago, almost 20, in order to make the notion of a promise available to IT systems design. I hope this is valid. Main principle of promise theory is that autonomy is essential. And the idea of an obligation is incompatible with autonomy. Decouple promise from obligation. And this is in sharp contrast to what philosophy has to say on the matter of promises. In philosophy, you will find that a promise is a mechanism which constructs an obligation. And precisely that claim about promises is denied in promise theory. Well, the fate of such kind of appraisal against philosophy is unclear, but it's a nice way to look at things. So the main assumption of promise theory is that promises do not create an obligation, and this leads to a drastic simplification of the logic of promising. Exit deontic logic. Then, so what does a promise instead? It produces expectations of agents. Agents are the promisee, and other agents in scope of the promise. And that is a context in which assessments will be made by the promisee and by agents in scope. And these assessments may affect the trust which the promiser can expect. So the promiser may feel entitled to trust in his or her environments, their environments, but this trust may be destroyed if promises are not kept. Here's an example. Person A promises to their friend B, on request of B, that they will transport B to the airport by car at some given time. Now A fails to show up. So what will happen? There are 3 options. B goes to court and claims compensation. B won't ask for the same service again. Second option. Third, B won't ask for the same service again, and B will tell their friends not to trust A in such matters. So, in the third option, there is a reputational damage for A. Now, I would say that in this kind of case, 2 and 3 are more plausible than 1. And 2 and 3 have nothing to do with this notion of an obligation. So what we see is that the promise made by A was part of a mechanism to get into a form of cooperation, which is voluntary for both sides. The thing fails because A doesn't show up and doesn't keep the promise. Well, the repercussions are on B. B will, of course, have a problem with going to the airport, but apart from that, B will remember this, and B may not be inclined to ask for the same once more, and B will suggest their friends to be careful with A on such matters. Now, I think that this example shows how promises can be used in order to get into voluntary cooperation. It also shows that promises are often created on request, and it shows that obligation need not be the critical mechanism which makes the promise useful or meaningful. So, by and large, not keeping a promise may have negative side effects on trust and on reputation. Now, a promise has 4 components: a promiser, an agent, which may be animate or inanimate, a body, which is a description of what is being promised, possibly including how, when, and where the promise has been issued. A promisee may also be a group of promisees, and a scope. The scope is the collection of agents who are made aware of the promise, and this is done by the promiser. So the minimal scope is that it's just the promisee. Some promises that we see on TV are made with worldwide scope. So today we saw the promise that tomorrow the Russian president will announce that 4 parts of Ukraine have been annexed into Russia. That's a promise with worldwide scope. Well, interestingly, factual statements may also be understood as promises. For instance, if I tell you my mobile phone number is this thing, which it isn't, then it may be a fact. It may not be a fact. But it can be understood as a promise, and as a promise, it doesn't really matter whether or not it is a fact. So these promises are less. No, the point of promises is not so much being true or false. Promises are speech actions which take place, and well, if you trust the promiser, the promiser, you may use this phone number. If you don't trust the person, you won't use it. The notion of truth doesn't necessarily enter this story. Promise theory is the theoretical basis for so-called alternative facts. So this is rather an alternative fact, because my phone number isn't actually this thing. Next, accusation theory. So Marcus Duell and myself had experiences in recent years which had to do with accusations made in the direction of certain persons, among which ourselves. And we found out that this notion of an accusation is a complicated thing. Somehow, at first sight, you end up, well, somehow we had to go through a learning curve about the notion of an accusation. And it came to our mind that an accusation, like a promise, has future effects in terms of expectations and in terms of trusts. And that's the main phenomenon about an accusation. Now, making an accusation requires some kind of justification. However, and this is critical, it doesn't create the requirement to prove the validity of the body. That's a different matter altogether. So what matters is some form of type correctness. There must be a plausible connection between the body of the accusation and the accusee. So, like in the case of promises, there is an absence of the creation of an obligation. Making an accusation does not create an obligation to prove that the body is valid. We all know that this is the case in a legal situation in court. If someone is accused of something, everybody knows that at the moment of accusation, the proof of validity of the accusation has not been given. The accusation may be made in the absence of a proof. What's given is the intention that a proof of the accusation, of the validity of the accusation, will be delivered. But it's not at all known that this will actually work out. So there is some notion of plausibility about accusations, which is weaker than the accusation actually being valid, which is what an accusation is about. And that's very much the same as with the promises. There is something about the promise that's weaker than an obligation. And that's what the promise is about. Here are accusations taken from last days. Magnus Carlsen accuses Hans Niemann of cheating. Everybody understands that it may take quite some time to prove or disprove this thing, but it really sets a scene. And what we see is that where promises are a mechanism for voluntary cooperation, this accusation made by Magnus Carlsen is a mechanism for voluntary non-cooperation. So not only he produces an accusation, he also claims that he doesn't want to play chess games with Niemann anymore. And well, of course, people dispute whether or not this accusation may be made, but it's done, and it gets throughout the news everywhere in the world. Well, the White House accuses the Kremlin of organizing fake referenda in parts of Ukraine. Yeah, is it a fake referendum just because Venezuela is not accepted as an external observer? I don't know. What we see is the accusation is made, and it's made in order to change people's mind. Russia has accused the NATO members of needlessly prolonging the war by supplying weapons to Ukraine. Well, it's a clear-cut accusation. Then we have Labour, which accuses the Tories of deliberately crashing the pound. Well, I don't think that Labour wants to prove this. It's just made in order to clarify to everybody that they disagree with the Tories. In Germany, we just had this long discussion about the Gasumlage. So the Christian Democrats accused the German government of turning this Gasumlage into a mess. Today, we got the news that the Gasumlage will not take place. Gasumlage was a particularly paradoxical thing, namely an additional taxation of gas in a policy that intends to reduce the cost of gas. So this is not a trivial thing to understand, and indeed they have stopped this policy. Now, accusation is primarily about affecting reputation. In many cases, proof of validity is almost irrelevant. What more can we say about accusation? Accusations deserve theoretical attention for the simple reason that there are so many of these. My 5 examples just were issued in the last week, and every day you find new examples. Accusation has been entirely neglected in philosophy. Marcus and I have, I think, found 10 papers, 8 of which by the same author. And this author very much thinks of accusations as playing a role in legal procedures. and this is quite a formal view on the matter, which is not explanatory for the kind of examples I just produced. Now, as I just said, if you assume that promises are a tool for achieving voluntary cooperation, then accusations are a tool for achieving the opposite, voluntary non-cooperation. And the legitimacy of an accusation primarily depends on the intention of an accuser to maintain the accusation and to accept the side effects on their reputation if proof of validity fails. So when proven wrong, the accuser either admits having damaged the accusee, or if not, accepts further reputational damage, if any, which comes from their dismissal of proof. So I would say that any interpretation of accusation which is more focused on the validity of the body of the accusation as an assertion disregards the monumental side effects on trust and reputation, which are the key phenomenon we see with accusations, at least outside legal procedures. Now, the definition of an accusation, as Marcus and I have written this down in our Transmathematica paper, has 4 components, just as a promise: an accuser, a body, that's the description of what state of affair it is that the accusee is accused of. An accusee, maybe more, maybe a group, and a scope, people made aware of the accusation by the accuser. In fact, factual statements may also be understood as accusations. For instance, a parent may say to their child, "You lost your mobile phone." And this is then not just a factual thing, but it's also an accusation. So whether or not an accusation is not governed by the keyword accusation made. So accusations can be, speech acts can be understood as accusations by an external observer. And well, it may be the case that they are not understood like this by the accuser, then it may be the case that one has to look in more detail into the situation. Quite often, however, these things are fairly clear. Well, I will have a case study on this matter, and this case study is very much about things that are going on now. So it's about the situation in the Ukraine. So we have seen an accusation by the White House that the Kremlin is planning an illegal annexation of parts of Ukraine. It's not just the White House which makes this accusation, but they are a key representative of accusers of this kind. Then, most importantly, the Kremlin has issued a threat that an attack on Russia may be met with a nuclear response. This is critical because after the annexation, these 4 provinces are part of Russia, according to the Russians. Then Kiev promised to recapture all parts of Ukraine that are currently occupied by Russians, including those parts which are, if we believe the news, to be annexed by Russia tomorrow. At least that I saw on CNN half an hour ago. Well, Kiev, not having any nuclear weapons at their disposal, as far as we know, is not able to promise to respond with nuclear weapons to a nuclear attack. I think this has all happened last week, in recent days. And the question is now what? Well, if Ukraine is not a NATO member, would it have been a NATO member? The White House could openly respond with a conditional threat involving a nuclear response. For a NATO member, it's clear that if it's attacked with a nuclear weapon by the Russians, NATO will respond with full force. This is what we think to be the case with NATO. If there would be a promise or threat by NATO or a NATO member to respond with conventional weapons to a Russian nuclear attack, this would make no impression. It was on the news today that the Polish government claims that NATO should respond with a devastating conventional attack. We all understand that this doesn't exist. Conventional weapons are not that devastating. Now, openly issuing a threat of a nuclear response, thereby risking World War III, is both implausible and unattractive for the White House. I think all of this is fairly clear. So what happened? What happened 2 days ago? The White House, here's a typo, that's Jake Sullivan, promised to the public that it has issued a threat in private to the Kremlin only. So this is a promise about a threat being made. And in fact, the White House promises to the public that the body of the threat that was made has the following feature. 1. So this was only communicated to the Kremlin. The US will act decisively, and the action will involve the use of nuclear weapons. 2. Said action is expected to be catastrophic for Russia. I read this in various media. I think that this all happened like this. So the White House, moreover, promises to the public that both aspects of said threat body have been communicated successfully to their counterparts in the Kremlin. Right. So we see here that with this threat that was made to the Kremlin, the notion of a scope really matters, because only the Kremlin was in scope. The public wasn't in scope, for the simple reason that there is no, it's very clear that the public cannot be in scope, because there's nothing that the public can, that the White House can openly say. If they would openly say this is a conventional response, it makes no impression. And if they openly say that it will be a nuclear weapon on Moscow, it is an overreaction. So the White House had no option left than to act in this way. And the nice thing about promises and accusations is that precisely this state of affairs I could see several hours before it actually happened. Then, this is not quite true what I've written here. The Russian nuclear threat towards a non-nuclear state constitutes a military novelty. It may have been the case that this kind of threat has happened before. This still has to be looked into in some detail. I think that the promise that it has made a nuclear threat in order to manage the Ukrainian battlefields is certainly a military novelty. So the White House has said that it issued a nuclear threat to the Kremlin, and it did so in order to manage an actual battlefield. What they want to achieve is that the battlefield is conventional, which they expect to win. It may be the case that the White House has responded with nothing less than World War III. Nobody knows. I would claim that this is an unacceptable risk for the world by all means. It's clear to me that the White House had no other option. But nevertheless, the fact that they had no other option indicates that there is a failure on the European security architecture. And this failure is that in response to a threat from the CSTO, that's the eastern counterpart of the NATO. So in response of a threat that they will use nuclear weapons on the battlefields, no proportional response can be issued by NATO members, because for NATO, it's all or nothing. Now, I think this is a very serious issue. So the fact that NATO cannot reply in a scaled version forces the Americans to issue threats which may be unacceptable, quite worrying. If only the NATO would be split and a part of NATO could support Ukraine, we will be better off. This led me to the following proposal. The UK exits from NATO so that the UK can produce threats by way of response towards the Kremlin without necessarily risking a World War III. And yeah, that then they might potentially rescue parts of Western Europe for the third time from eastbound aggression. I now understood that there is an alternative. And this alternative is that the Americans provide Ukraine with nuclear weapons. Perhaps this is already happening. I don't know. There are very few options left for NATO members to manage this situation, given the fact that there is no indication at all that the Kremlin will not simply execute what they promised to do. Well, this is the end of my part on promises and accusations. We could have a few minutes of discussion first, and then I carry on with the fracterms.
Yep, that seems like a good idea that we discuss this now. I wanted to pick up on non-nuclear states being threatened with nuclear attack. There is, of course, a trivial case where that has happened before, which was Japan in the Second World War. It was a non-nuclear state. It was attacked twice by the USA with nuclear weapons, and there was at least an implicit threat that there would be further attacks, and that led to the capitulation of Japan. More recently, Iraq was threatened with nuclear attack by a US TV commentator. That was a statement in public. At the time, Iraq claimed falsely to be a nuclear power. So that is another case where a non-nuclear state has been threatened with nuclear attack. There may be others, but those are the two I can think of.
Yeah, the first case I find not so convincing because these first attacks were not preceded, I think, by threats. They were just made. Nevertheless, I think that by and large, this nuclear threat in an actual war is a new thing. It's not something we have seen before. And the Iraq case is unclear. That's true, but I don't think that the example you made was as official as Jake Sullivan speaking from the White House. Jake is the national security advisor. He is the kind of person who is supposed to say such things. There is no higher authority.
What I see here is that promise theory is being used as a tool in analytical philosophy. You're dealing with a real-world problem of how we live and using the methods of promise theory to tease out the issues. Do you think that's a fair characterization of how you're using promise theory here?
Well, it's at least a fair characterization of what we try to do, what I try to do. Whether it's successful is another matter. But yes, I think that promises, the nice thing about this promise theory for me is that, and promises and threats, accusations, apologies, it's something similar. The promise theory allows you to think in several dimensions about these things and to see the strength of these speech acts. So in the conflict situation where we used accusation theory when it wasn't just written on paper, in personal conflicts that we noticed, it turned out to be very useful to understand that an accusation was made in order to make reputational damage. And that only if you look at it that way, you start thinking about a response that's reasonable. And so I think that my use of these notions here is intends to get at a better understanding of these social phenomena. And then you have a terminology which is much less dependent on notions of like truths, because it's so difficult to list long sequences of true statements about social phenomena. You can't get there. And so this is much less dependent on claims of truth. And I think that is important.
So I have a couple of questions as well, Jan, if I may.
Of course.
So if we go back to the start when you talked about trust, I think there was an interesting connection there between trust and promises. And one more thing that you didn't actually mention, but which is one of your contributions to promise theory, the idea of impositions. So when I originally came up with the idea of promise, I think of this as a voluntary act, an autonomous act, make a promise about what I'm able to do, and I can only make promises about my own behavior. And the same is true of any kind of agent, animate or inanimate. So the degree to which someone else would accept my promise or not is a kind of promise also. And this is based on some trust in the original promise. What you pointed out years ago was that there's also the concept of an imposition, which where you like throw something at someone, you throw a statement which is somehow unexpected in an attempt to perhaps coerce or induce cooperation unwillingly, or sort of against will. And this seems to be somewhat related to this notion of an accusation and also a threat. So we now have promises, threats, accusations, and these impositions, which are related to, well, within the framework of promise theory. So would you say that accusations are a form of promise or imposition where the idea is an attempt to discredit or reduce the trust in the other party to the scope, the audience and scope?
So I think that the difference, in my view, the difference between an accusation and an imposition is that the accusation doesn't really suggest that the accused should do anything, whatever. Whereas the imposition, the way we looked at it, is a strong suggestion to the other side to get something done. And that connotation is absent from the accusation. But having said that, these things have much in common. And what I missed is that accusation has a counterpart that this is praise. Whether something is an accusation or praise is a matter of assessment. So, and I think that happens very much in the case of Ukraine too. So it's what can be an accusation in the perception of one person may be a praise in the mind of another. So I think that in the theory we have at the moment, impositions are slightly different from accusations, but all of these notions are deeply connected. That's completely clear.
It's interesting. I think what I understood now is that what I was going to say was that an imposition is, you could understand an accusation as an imposition in the sense that you're imposing upon somebody the body of the accusation, to accept it whether they want to or not. So in that sense,
it's true, yes.
But what is interesting is that the audience that you're trying to influence is the complement of the scope. So whereas the promisee is sort of the intended recipient of a promise or the imposition, the intended audience for an accusation is somehow the rest of the scope.
Quite often that is true. And it may even be, it's even plausible in an accusation that the accusee is not part of the scope. So that the accusee is that people are made aware of the accusation, whereas the accusee is not aware of this happening. And I think that's less the case with a promise. It could be imagined with a promise too, but with an accusation, this happens daily. Yeah.
That's very interesting. As you know, I've been working a little bit on the deeper notion of trust underlying these promises as well, and wanted to submit something in time for the conference, but wasn't really able to plausibly put it all together in time. But I think in the future it would be very interesting to bring these ideas together into a framework where trust plays a deeper role.
Trust is a kind of gravitation field behind all of this.
Can I just say,
glues
Mark,
people together or it splits people.
could I interrupt a moment?
Yeah.
Could I say to Mark that if you have things you want to say about promise theory, you can say them in the workshop section.
Yeah, I understand.
Okay, let's carry on. Yeah.
Yeah.
Now, so this is about, oh, this is the first one, yeah, about summary results on transrationals with John Tucker. Well, a frac-free term is a term which doesn't involve division, a term in the world of rings and fields. A Diophantine equation is an equation of the form t equals 0 and all coefficients are frac-free. Solvability of Diophantine equations over the integers is known to be undecidable. Result by Matiasevich. Decidability of solvability of Diophantine equations over the rationals is a long-standing open problem. Now, with this Q plus or minus infinity and nullity, I will denote the structure of transrational numbers, and that's a minimal subalgebra of the structure of transreals, which all of us know. Now, let T and R be two terms for the signature of transreals. There is no ordering. Then the equality of T and R, T is equal to R in this structure. Well, this turnstile thing expresses that the equation T equals R is valid in the structure of transrationals. Now, first result I want to mention is that the problem of deciding whether or not an equation is true in the structure of transrationals is one-one reducible to the complement of the problem of solvability of Diophantine equations over the rational numbers. Yeah, I think we have shown that. It's not yet published, but it has been submitted to, as part of a paper, to the ACM transactions of computational logic. We may or may not get it published. There was a mistake in that paper, which was found by the reviewers, and we had to do quite some work to solve that mistake, but we did, as far as we know. Next, eager equality. Suppose you have an absorptive element like nullity. Then eager equality is defined as follows. P and Q are eagerly equal if either one of P is nullity or Q is nullity, or both are equal and not nullity. So now every mathematician will immediately point out that this thing is not transitive, which is true, because 0 in this world is eagerly equal to nullity, which is eagerly equal to 1, while 0 is not 1. But it's almost transitive. If we know that the thing in the middle differs from something, then we can make the transitive conclusion. I think, well, eager equality may be criticized because it doesn't meet all requirements of equalities, but there are other equality relations in the literature which also have defects. So these kinds of defects don't necessarily imply that you don't speak about an equality relation. Now, the theorem that we could prove is that eager equality is decidable on transrationals. And that's not an obvious thing. We have done the work in detail for the wheel of rationals that involves a single unsigned infinity. And the situation is very much the same for transrationals. The proof uses fractal flattening in a common meadow. That's just another structure. as well as the continuity of division in a one-point compactification of the reals. I would say this, I still hope that all we are doing is correct, but it looks like real mathematics. And so what we find is that eager equality may well be simpler than native equality, because native equality is one reducible to the problem of solvability of Diophantine equations, and it can be done the other way around as well. This might still be undecidable, and if it's decidable, if it is decidable, which has yet to be shown, if it were, then it's very complicated. I have no doubt. So I think that this situation indicates that eager equality is fundamentally simpler than native equality, which is a nice thing. Next, symmetric transrationals. In the world of transrationals, there is a certain asymmetry because division by zero produces positive infinity, and it could also produce negative infinity. This is a non-obvious thing. At least from a mathematical point of view, it would be nice to see into the situation where you don't have this asymmetry. Now, that's simple. You start with a common meadow, a world where 1/0 is nullity. That's a known structure. And then you don't add two peripheral numbers, infinity and its negation, its opposite, but you add 4. You also have infinitesimal values, iota and minus iota. And now you have 1/infinity is iota. Well, it's not so difficult to get a definition of this kind of structure. It looks quite plausible. And what it produces is what we call the arithmetical data type of symmetric transrationals. We were able to show that the problem of deciding equality of an equation in this thing is 1/1 reducible to the complement of the problem of solvability of Diophantine equations over the rationals, just as in the case of the transrationals. This problem, this proof took us 5 or 6 pages. It's quite a task. Probably this kind of phenomenon is quite general and is not specific for this structure, but we have not found a general story about these matters, which works in a more general way for a range of arithmetical data types. I expect that such things can be found on the long run. This structure of symmetric transrationals turns out to be interesting, I would say, because one could imagine that floating point would be introduced like this. Now let me first move back. So what you have here is that 1/0 is just understood as some kind of error, where 1/infinity is not. Of course, the strange thing is that there is no way to get infinity, because 1/0 doesn't work anymore. So these infinities and these infinitesimals sort of don't show up in the data type. You never get there. But of course, you could imagine that you get there by overflow. An overflow might be positive overflow might be identified with infinity, and a negative overflow with minus infinity. And then if you divide by a positive overflow, you get iota, and so on. So if we think in terms of an overflow, then If we think in terms of an overflow, then the overflow, then an overflow can be assumed, say, at a bound B. B should be larger than 1. So if you get a result larger than B, it's identified as omega. If you get it smaller than -1, then minus B is minus omega, and so on. Well, with a superscript B, I denote the symmetric transrationals, which are modified in such a manner that it works as I just said. If you have a result larger than B, it's now said to be plus omega, plus infinity. But this doesn't change that division by 0 just produces nullity. Well, you have corresponding modifications for negative numbers. This produces the structure of bounded symmetric transrationals with bound B. Now we have the following facts. Precisely if B is larger or equal than 2, it is the case that this structure is a so-called minimal algebra, that all elements of this structure are interpretations of closed terms. And that's what you need for these things to be a data type, an arithmetical data type. The nice thing about these bounded symmetric transrationals is that it produces a pathway to investigating the occurrence of faults and errors in programs computing on such structures. So in the theoretical world, of course, you can have programs that work on an infinite set of rationals, but that's not how computers work. And well, because the actual floating point reals are far too complicated to serve as a platform for theoretical work, this kind of structure is different. In bounded symmetric transrationals, you can indeed somehow investigate the theory of programs working in a finite world and take into account errors, faults having to do with overflow. Well, that's just a matter of motivation. This result is the last thing I wanted to say about transrationals as outcome of work in last year. Thanks.
Okay, thank you, Jan. I'd like to ask a question, well, make an observation about the symmetric transrationals. They relate to the transcomplex numbers. So your infinitesimal numbers, when you divide by those give you all and only the points on the line at infinity. You have nullity left over. In geometrical terms, if you think of the Riemann sphere, your infinitesimals are on a circle that asymptotes but does not arrive at the North Pole. The North Pole is then nullity. So there is a clear geometrical background to what you've presented algebraically. I would encourage people to explore the geometry behind algebra because it's more likely to find a route into physics. So if you've got an algebraic structure that has a geometrical interpretation, I think it's more likely that you can map those spaces onto physical spaces and do things with it. So that's just an observation. In addition, I'd like to point out that how your infinitesimals relate to IEEE 754 floating point arithmetic. So that arithmetic has two infinitesimals, 0 and -0. The standard is inconsistent. So -0 equals 0 by axiom, by definition in the standard. 1 over -0 equals -infinity. 1 over 0 equals +infinity. -infinity is not equal to infinity. Therefore, -0 is not equal to 0. So the standard is inconsistent. And the experience of software engineers is that -0 causes faults. It leads people to misunderstand and write buggy programs. Now, you might rescue the IEEE standard by saying that the equality is some special kind of equality, but that fact hasn't been communicated to programmers. So that's all I wanted to say about the relationship of your algebra to...
Yeah, about the geometry. Geometry is really not my field. I've noticed early on as a student. It's a very complicated thing. And yeah, I think that it's something to be done by other people. Not that there is anything against it, but it's clearly why I'm not a pure mathematician. Pure mathematicians must be much stronger in geometry than I am. Much.
In my experience, algebraicists tend not to be good at geometry and vice versa. It seems to be separate worlds, and there seem to be very few geometers in modern mathematics.
Well, many people identify themselves as working in algebraic geometry, and they do both.
Of course.
Yeah, it's big.
I'll give you that one.
But it's, yeah, it's a very professional matter, that's clear. Yeah, and about this relation with floating point, yeah, what I can only say is that from a theoretical point of view, it's not easy to understand floating points, whereas it's quite easy to understand these things.
Yeah.
And yeah, and indeed, it may be that these things can be embedded in the transcomplex numbers. That would be an interesting result, which could be explored further.
So actually, I have a follow-up question to James' point, which I think James' point is very interesting to me, because as Jan at least knows, my background is in physics, theoretical physics, where all of these geometrical notions, of course, extremely important, and the connection between algebra and geometry is very clear in quantum mechanics, of course. So what I was thinking as you were giving this example of 1 divided by 0 being either plus or minus infinity, is that this is very similar to issues that I've been looking at, coming back to the promise theory again, that these expressions in mathematics, equivalence relations and relationships in numbers, are basically obligations. They are imposed upon all of the all of the numbers in the number line. They don't get a chance to say whether they accept it or not. Yeah.
Mm-hmm.
But of course, so one interesting aspect, one interesting approach to this might be to consider the numbers to be agents. Well, are they willing to accept these things or not? And the reason I say this is that the concept of an agent with a directional promise, it has that direction plus or minus to be able to say, are you going in one direction or the other direction? This is somewhat related to the notion of plus and minus 0. Are you coming from above or from below? You know, there's an orientation involved, which is missing from the equivalence relation and yet exists for all processes. And the thing that I've been almost, I don't know, well, let's just say involved in the last few years is distinguishing very clearly between what is a statement about a thing and what is a process. And physics is really all about processes, although we misrepresent it all the time as it's a story about things, bodies in space and time.
But it's always processes.
It's always processes. And because we separate things from space and time, we muddle this up all the time. And I wonder if the same thing isn't going on to some extent in the way we define quantities and numbers. And if we were somehow to look at them as processes, would we be able to see the difference between these left and right, plus and minus? Of course, in politics, it's very easy. If you go far enough left or far enough right, you sort of end up in the same place, a giant war or something. But in mathematics, you need to be more subtle. And just to give a simple example, before we move on, this idea of quantum entanglement is very mysterious and leads to all kinds of crazy things that people think is very hard to understand. What I realized is that if you understand electrons as not particles, but as processes with interior degrees of freedom, then it's very clear why entanglement should be the way that it is. And you can generate all of the traditional results of quantum mechanics, pardon me, very simply by seeing an electron not as a thing, but as a process. And this is somehow baked into the equations of quantum mechanics because they're process equations. We know that there are waves involved, excuse me, but if you, instead of externalizing the waves between these particles, they're inside the electron. They're inside the agent. The agent itself is a process. Suddenly all of that mysterious difficulty disappears because there's an orientation involved. But the orientation is kind of hidden from view. So the promise is out of scope for the observer. And I wonder if all of this fascinating mathematics could find a representation in terms of agents in which there are properties of the numbers that are somehow interior. An orientation is one looking forwards or backwards. It's a crazy idea, but
yeah, of course, in constructive mathematics, there's quite a tradition of understanding a number as a process. So the constructive understanding of intuitionistic mathematics tries to look at everything as a process. Difficulty is that it can be done in many different ways. So it doesn't easily lead to the clear-cut kind of story that classical mathematics produces. But I think that a process understanding of numbers is certainly something that has been looked at quite intensely. But it's quite remote from what I'm doing. That's obvious. Yeah.
very interesting.
Yeah, I would like to do two questions. The first one is, I didn't understand very well what is the set Q power B. What is exactly this structure? Is the set of rational numbers with the arithmetical operations modified?
Modified, yes. So every number in it is lower than B. B is identified with infinity. And so if B would be 10, then 6 plus 6 is larger than 10 and therefore is infinite.
Okay. You bounded the set,
yeah,
with the parameter. Oh, okay. Yes, and when you talked about the iota, the plus and minus iota, with as infinitesimals, it remembers me the set of the hyperreal numbers that are the set with infinitesimals. And did you consider hyperreal numbers in this case? What do you think is the relation about your proposal with hyperreal numbers?
I must admit that I don't know. Yeah. There might be a relation, but I don't know.
Okay.
But I guess that this structure is simpler. And I would also expect that the hyperreal numbers are not an extension of this common meadow. That in the hyperreals you don't have something like 1/0 is nullity. And precisely that substructure we have studied in very much detail, John Tucker and I.
There is a clear difference as Jan presented it. The infinitesimals are close to 0. They don't occur everywhere as they would in the hyperreals.
Yeah.
That's a clear difference.